can always bring bring up any concern you have in the class. I'll be happy to discuss it. No problem. So I am recording the session. So we have a section where this still goes on application of derivatives. One of the applications of derivatives is uh, curve sketching. We're gonna sketch the curve using the help of derivatives, which we haven't done before we take derivatives. So, okay, so these are classified, the curve sketching process has the following steps, right? We're gonna find first intervals of increasing and decreasing, intervals of increasing and decreasing Okay, where is what is interval, what is increasing, decreasing, and where is a function increasing, where is a function decreasing, right? So what is the intervals of increasing? I can define them here. A function is called increasing, you know. If it is, okay, maybe this summarize better. Sign, based on the sign as a derivative, we can tell that the function is increasing or decreasing. Sign of the derivative and conclusion. If the derivative of a function is positive, that means what? That means that the slope of the tangent line is positive. That is the slope. Remember, the derivative stands for the slope. So therefore, then the function is increasing. So if the sign of the derivative is negative, then f of x is decreasing. An example could be, you know, if you have a graph like that, right? So as you can see from this point, let me call this x0. This is, let me call this x1, you know. So f, the function, the given graph, this is y equal to f of x. So as you can see, this graph from x0 to the left, the f of x is increasing, since the tangent line to that is positive. The tangent line to that has a positive slope. The derivative of that, which is the slope of the tangent line, is positive. Okay, so from negative x, from x0 up to x1, as you can see, the tangent line to that curve is decreasing. It's a negative. It's falling. The line is falling. So f of x is decreasing. Right? But f of x is increasing, then the derivative must be positive, right? This implies the derivative is positive for that interval. This implies the derivative is negative because the line would be like that. If you take a point in between these two intervals in here, right, then the tangent line will be like that. So it's actually a negative slope. Okay, so from x1 interval up to the right side, infinity, x up to the right side, which is infinity, then f of x is again what? Increasing. As you can see, take a point here, take a tangent line, that is a positive slope line, so is increasing. As you know, decreasing means the derivative is less than 0. As the increasing means the derivative is greater than 0. That's what the way we see it in differential calculus. Increasing graph or a graph with tangent line positive is when the derivative is greater than 0. Decreasing line is decreasing graph is a graph in an interval in such a way that the tangent line has a negative slope. That's what we say. So the tangent, which is the derivative, which is which describes the slope, really is a criteria for whether a function is increasing or decreasing. So it is very important, as far as I'm concerned, if the derivative can tell you if the graph is increasing or decreasing, then that is one application of differentiation. Okay, so one step is to know in which interval is the graph increasing, in which interval is the graph decreasing, and so on. And this is measured by this criteria. I gave you a table here, right? The conclusion and the condition. So if the sign of the derivative is positive, then the function is increasing in that interval. If the sign of the derivative is negative, then f of x is decreasing. Okay. All right. The second knowledge we have is these points of what we call local minima and local maxima. The second see, curve sketching process has the following steps. So I call them steps, right? So the second step is to find those points. You see, those are called local minimum and local maximum, right? So finding the local maximum point, finding the local minimum and maximum points. That's the second step. So as you can see, this is a local, this is not a total maximum because this graph goes indefinitely up. So you can't call it just maximum, but it is a local maximum. In its neighborhood, it is a maximum point. In this neighborhood, on the x1 neighborhood, the point x1 has a y value which is minimum. That's called, so if I had this x1 and y1, and then in my graph, or let me call it M. So in this one, x0 and capital M. So that capital M is local maximum because in the interval around x0, then the y value will be below, every y value will be below M. In the interval of x1, every y value of every x in that interval around x1 must be greater than m, little m. So that little m, or that point where it has little m, is called local minimum, and that point where it has capital M is called local maximum points. Okay, so we're going to take advantage of this local minimum and maximum points in order to sketch a curve, right? So I'm going to define them in detail. Point I don't want to say M. The book says M. A point M. Okay, I will refine it. A point M is called a local maximum point. Local maximum point. So I should say a point M is, instead of that, a point XM is called a local maximum point. local maximum point if in the neighborhood of the interval x, that is a maximum number, right? Okay, so this maximum if I will say this, if no nearby, is that better? No nearby no nearby point has higher value than m, a point x little m is called a local minimum point if no nearby point. The nearby is not clear, but it is at least in the neighborhood of where x is. Okay, so nearby point has a lower value than m. Okay, I hope that will explain what local minima and what local maxima are, right? But what is the condition that we know about this local minima and local maxima? What is the condition? So what we have, what we call first, how do we find them really? How do we find them? So actually, in the local maxima, you see, this what would be the slope is my question. Who can help me? At around the local maxima and at around the local minimum, what is the tangent line? What is it? What kind of line is that? Is it decreasing, increasing, or Arthur said, yes, you're right. Arthur is zero, side zero, and of course the Wissam, yes, zero. It's horizontal. The lines are horizontal. The tangent lines will be horizontal. A horizontal line has a slope. Actually, you got it. Very good. So therefore, when we're trying to find the local minimum and local maximum points, then we have to set the derivative equal to zero. Okay, so we can find the x values, x points, which we call them, I call them critical numbers. Only for the x values. So we can find the points, the x points of the local, they call them extrema, for both minima and maxima, they call them local extrema, but it's okay. Local minimum and maximum, we can find the x points or critical numbers of the local minimum and maximum by setting the derivative to zero. Why? By setting the derivative, which is a slope, the derivative, which is a slope of the tangent line. It all makes sense with the slope of the tangent line to zero. If it's to zero, okay. So if you have a function f of x, you're trying to sketch the graph of f of x, some function, then if you say that f prime of x equal to zero, then the x value you get will be critical number. Okay, so the x value you get will be critical number. I'll take an example, and also say, for example, just for this local one. I'm going to take example for all. But I'll wait for an example, because I'm gonna give an example, and then we will take care of step 1, step 2, step 3 for that example. Okay, so that's good enough. And we have, under this, we're gonna use what we call first derivative test. There is as soon as we get the critical numbers, we don't know if they are minimum and maximum points, you know. So how do we, okay, I will ask, how do we know if the points are, the critical numbers are points of maxima or minima, points of local maxima and minimum? Yeah, we have what we call first derivative test. This first derivative test is I will how do we find the local? I will make it like a pictorial definition, not definition, just a guideline. Local maximum and local minimum. What do I know to find them? Well, f prime of x should be equal to 0. I will find the number. Then, if local maximum, you can see that it should be looking like this, right? Suppose this is a point that you find from here. Suppose this is x1 here you found. That point is x1 and maximum for that. So what do we know? What do we know about x1? The slope when you're passing x1 from left to right. When passing x1 from left to right, passing x1 from left to right, the slope changes from what? What was the slope on the left side? See, here is, just take a random point, take a random point and take the tangent line. It shows you it's a positive slope, so therefore it's increasing. So when you pass that point, the slope changes from positive to negative. You see? So the slope changes from positive to negative. Okay. When you're passing, okay, local minimum, the same way you find it, you're going to find it by setting f prime of x equal to 0. And then it's going to look like this. And this is the local minimum. If when you pass it from left to right, and then this is negative slope, this is positive slope. Okay, so the slope changes from negative to positive. This is what we call first derivative test. And we can make a chart and make it clear by dividing the intervals created by the boundary points of the critical numbers. Okay, I will explain what I mean by that. It's time to take, I don't want to continue because it's too much information. So we're going to take examples of step 1, step 2. And of course, let me call step 3 like for the first derivative test. Okay. So let's take example from the problem set. So I guess I will do number 6, for example. Y equal to, okay, this is on section section 24.5 on page 748. So what I have is number 6. They say for which value, for which interval or intervals is the function increasing or decreasing. Okay, what is the function? So y equal to 2 plus 6x minus 3x squared. I think I will also say, I will also ask you find the critical numbers, because without that you can't find the increasing, decreasing. Okay, so of course, if you are asked to find the increasing and decreasing, you should click to mind the slope, right? That's how we measure, right? Remember our definition of increasing and decreasing? The slope greater than 0, it's increasing. The slope less than 0, it's decreasing. Okay, but before you do the increasing, decreasing, I think it's better the derivative of dy by dx, which is the f prime of x, which is 6 minus 6x. You should get the critical numbers by, this is finding the critical numbers. This is step 2. They are all connected. I'll show you. So finding the critical numbers is setting the derivative equal to 0. That means that where is a point on the like, you know, what do we call those? Those are the local maximum, local minimum, where those bending points or saddle points. Okay, so by saying, by pushing that into, if you solve this, then, well, you know, 6 equal to 6x, then x equal to 1. There is only one critical number. Okay, so therefore the whole line is divided by 2, sort of from 1 up to infinity and from 1 up to negative infinity. That's it. So I can put it in a chart, you know. So the critical number is very important. That's where it creates the intervals. The critical number is the point where it's maximum or minimum. So your increasing, decreasing is also dependent on those numbers. So in this case, I have 1, and then there is x greater than 1, and there is x less than 1. Okay, do not include even the 1. That is the boundary line. That is where, what is that 1? That's where the slope is 0. Okay, so where is so what is the slope? The f of x, as you know, it is what? 6 minus 6x. So let's investigate the sign of the slope. What happens to the sign if I take a number less than 1? Remember, the critical point is a point where the graph changes from increasing to decreasing, or from decreasing to increasing, vice versa. That is where there is no other. If we had another critical point in the graph, then there would have another banding, or there would have been more turning point. Okay, so there is only one turning point, so the graph has the same nature. On the left side of the graph, it's always increasing. On the right side, it's always decreasing until there is another turning point, and then it's always increasing until there is another turning point. That's what it is. There is no way that we can have another turning point, because the derivative would have, or the fact that setting the derivative equal to 0 would have given us another point if there exists another turning point. So in this case, this is parabola, you know. Okay, there is only one turning point. That's why we got one critical number. So therefore, let's investigate if this one is, what do you call it, maximum point or minimum point. Well, what is the sign of the derivative for any number less than x, less than 1? Take a number 0, for example, x equal to 0. If we take for one value, it will be good enough. So for x equal to 0, this is positive, right? For any number less than 1, it's positive, isn't it? Arthur, yeah. Slope, yeah. So what is the derivative, which is a slope, equal to that? What is the sign of it? I want to check the sign so I can know, I can tell which one is increasing, which one is decreasing. So what is the derivative when it's less than 1? Well, take a number less than 1. Take, for example, 0. It's a better one. So if you put 0, you get 6 minus 0 is positive 6. So the slope is positive for any number less than 1. You can check any other number. Okay, let's take x equal to negative 7. So 6 minus 6 times 7, negative 7 is 42 plus 6, which is 48. Okay, so for all the numbers less than the critical number, they have the same sign. Okay, what happens if you plug in x equal to x greater than 1 into the derivative? The derivative becomes, say, 2. Let's take 2 because it's x is greater than. I'm working on the right hand side. Okay, what happens if we plug 2? Then 6 minus 12 is negative. See? So when passing a critical number, from left to right, you get a positive changing into negative. See? So a positive slope changing into negative slope. What is that then? Is it maximum point or minimum point? Maximum, exactly, by our definition. The definition is saying here, when passing from, right? Okay. Anyway, well, but passing x1 from left to right, the slope changes from positive to negative, it is maximum. When the slope changes from negative to positive, it's minimum. So definitely this is positive. This is positive graph. It's actually increasing. It's increasing like that for that interval. It's decreasing like that for that interval. So that point is maximum point, really. This is called sign chart. So therefore, the point, I will find the point 1, comma, we're going to find y. That's what we got. Is what? A point of maximum, point of local maximum. Okay, what is y, by the way? I can find that y equal to 2 plus 6x minus 3x squared. When you find the y value, you always go to the, not the derivative, you go to the original function. So if x is 1, this is x equal to 1. So plug x equal to 1. What is y? 2 plus 6 is 8, minus 3 is 5. So it is 1 and 5. Right? Let's plug 1. 2 is 6, 8 minus 3 is 5. Yeah. So the 0.15 is a point of local maxima. Okay. Right. So what is the interval? And the graph or the function is increasing. Increasing where? Increasing where there is positive slope by our definition. Remember our definition? If it has positive slope, it's increasing in our chart here. If it has positive slope, it's increasing. If it has negative slope, it's decreasing. Okay, so where is the slope? The slope is already determined on this chart. The slope is positive, meaning that it is increasing. See, what is the interval increasing? X less than 1. So, and the function is increasing in the interval of that. Or you can say this is negative infinity 1. You can exclude it, include it, doesn't matter. We're talking about interval. And the function is decreasing. Where is the slope negative from the chart? Decreasing in the interval. See, in our chart here, this is, let me call it sign chart, because I am deciding on the based on the sign of the slope. This is the slope, okay, the derivative, and it has negative sign. Because it's negative sign, then the interval would be interval of decreasing. So x greater than 0, see the interval, x greater than 1. So the function is decreasing in the interval of x greater than 1, x greater than 1. So you can write it is 1 and above, right? Now, what is the point of the critical point? We said we already decided that the 0.15 is the point of local maximum. So we did two things. One is we found the point of minima and maxima. The second one is we found the intervals of increasing and decreasing for this question. I hope you followed me. I took very easy question. Okay, is that okay? Or we can can I use another example quickly? Sivan? Okay, if you have about 5 minutes, I can use another example. A little bit harder, like number 8. Y equal to x to the 4 minus 6x squared. No, actually I will do number 12. The question, I want to make it bigger. So the question is find the local, find any local minimum and maximum. Critical numbers and increasing and decreasing intervals. So we're going to find all of this. To find the local minimum and local maximum, what did we say we should do? What is the criteria? To find the critical number, what is the first start? Always start by finding the derivative equal to 0. Excellent. Thank you, Sam. So the derivative dy, this is a solution. When you find the slope dy by dx and is headed to 0, it means that you're finding the critical number. You're finding the point where the graph, the tangent line is horizontal. You're finding where the point where the tangent line is horizontal because the slope is 0. Okay, so what is the derivative for this? The derivative for this is dy by dx is 4x cubed minus 12x. I found the derivative. And when I set 0, then I got to factor, like, because there is x on both and there is 4 on both, I can factor 4x. And then I have x squared minus 3 equal to 0. Is that it is? So, a product of a times b is equal to 0. If a is equal to 0 and b equal to 0, that's what we do, right? This is fundamental algebraic property. So this first factor is 0, comma, the second factor, x squared minus 3 equals 0. This will generate every critical number. And then the first one is x equal to 0 over 4. The second one, x squared equal to 3. Then x is plus or minus root 3. So there are 3 critical numbers. X equal to 0, x equal to negative root 3, x equal to root 3 are all the critical numbers. So as you can see, there are 3 up and down, or 3 turning points for this graph, because the graph is power of 4. Then in the 3, 1, 2, 3. You know what I mean? That's what we're gonna, or it could be like that, the turning point. Okay, I don't know. So, but because of power 4, when the degree of a polynomial is increased, the turning points will increase, the chance of the turning point. So this, is that clear how I found my critical numbers? How I solve them? I find the derivative, set it to 0, and from here down, it's your skills in algebra, you know, what we learned in 128. Okay, so you find the derivative equal to 0 and solve for x, and solve for x, solve for x. That's what I have been doing. And every number you get is a critical number. A critical number is a turning number on the x component of the turning point. Okay, that means the graph is going under 3 turns. Okay, now how do I find the so you made your chart, you know, the sign chart, which will help you decide on where is the graph increasing, where is the graph decreasing, where the graph is maximum point, where the graph's minimum point, and all this will be determined by the sign chart. So I'm going to have a big x-axis, because this x-axis is divided in 3, maybe more than 3 intervals. Okay, so you always order your x-axis. This is x-axis. You order them based on increasing. Based on value. So the smallest number on the left, so it's negative root 3, and then the next number is 0. The next bigger number is 0, which is 0 here, and then next one is root 3. That's the biggest number. So we have created x less than negative root 3 to the left of root 3, and x in between negative root 3 and 0, and then x falling between 0 and root 3, and then finally x is greater than root 3. So how many intervals? 1, 2, 3, 4 intervals. We have to determine what the sign of the derivative, or what is the sign of the slope. What is the slope? The slope is this. The derivative is 4x cubed minus 12x. Dy by dx equal to 4x cubed minus 12x. Question. That's why I called it sign chart. What is the sign in here, in this interval, in this interval, in this interval, in this interval? We don't care about the critical numbers, as you know. The critical numbers, the sign of the derivative at the critical numbers is, there is no sign, it is 0. So neither positive nor negative, it's 0. So we're not concerned about the critical numbers sign. We are concerned about the intervals. Okay, what is the sign of, for every value, all you take is, this is easy in a way, because all you take is a sample value in that interval and plug it to the derivatives equation. So what, can you give me a number less than negative root 3? Any easy number which is less than negative root 3 as a sample for this group. Okay, so Arthur, I like Arthur's. Negative 2 is easier than negative 5, especially for me when I'm struggling with my numbers. I will take negative 2 with some, you don't mind. Both are good though. Okay, so when I plug x equal to negative 2 here, so negative 2 to the 3 is negative 8. Negative 8 times 4 is negative 32. Negative 2 times 12 is plus 24. So I get negative 8. So this is negative. Check it. Plug a number less than negative root 3 into the derivative, and then give me the sign of the derivative. The sign of, investigating for the sign of the derivative, because that will determine everything. So I am taking a sample from the left of negative root 3. I took a negative 2. I plug it. Negative 2 cubed is negative 8 times 4 is negative 32. Plus 24 is negative 8. So I don't need the value. I just need the sign. So what happens between negative root 3 less than x less than 0? Let's take negative 1, for example. Okay? At negative 1, it is 4 minus 4 plus 12, which is positive. So what happens between 0 and root 3? Like take 1. Take x equal to 1 inside. Take x equal to... These are not part of the work. This is your choice. X equal to 1 is falling between 0 and root 3. So 1 is 4 minus, this is negative. And then x greater than root 3, let's say 2. If we take 2, this would be like positive 8. See, this is your sign chart. Based on this chart, you will determine, so where is the function increasing? So increasing, the function is increasing. Function is increasing where? Increasing when there is positive exponent. I mean, when there is positive derivative, the sign. So function is increasing in the following interval: negative root 3, or there is less than negative root 3, less than x less than 0, comma, or union x greater than root 3. On both intervals, the function is increasing. So while you can write it in interval format, negative root 3 and 0, and then root 3 and infinity. Many people prefer this instead of less than greater than. So the function is decreasing. Decreasing where? Decreasing when the slope is negative. The slope is negative where? At x less than negative root 3, and at x at 0 less than x less than root 3. I am reading from here, from the chart, the top. So therefore, some people prefer this as negative infinity, negative root 3, and union, what they call it, union. Union means you're adding, just, it's okay, comma is good enough. And 0 root 3. Is it root 3? Yeah. All right. We finished the job of increasing, decreasing. Now the question is, where is maximum, minimum? Maximum, minimum. Let's investigate. The chart is everything. You know, this is going down and this is going up. So obviously at this point it's minimum. This is going down, this is going up. Obviously this is minimum. But at 0 it's maximum, because this is, the slope is up and going down right after. So this must be maximum point. The slope is down on the negative root 3 and then up after. So this is minimum. You see, based on, I'm drawing here just a guideline for myself. I shouldn't do, but a guideline. The negative means declining line, positive means increasing line. Then the point where the turning point would be, in this case, obviously, is the minimum point. So right after I have a positive slope, there is a negative slope, so it must be going down. So that x equals 0 must be a point of maximum. And then right after, to the right side of root 3, then the slope is positive. So therefore, that point is actually a point of minimum. So therefore, you can tell me the points of minimum are. Give me 1 second. So the point of minimum, what are they? Negative root 3, I have to find for y, and root 3. And I have to find for y. I know some of you might have found it already. All right, thank you so much, Arthur. Yes, when you put negative root 3, what is y? You know, you go back to the original one. Don't make a mistake. You go back here. If you put root 3 here, Arthur found it, and you can always find it. So it is negative 9, he said, because I don't have time. So I'm going to take negative 9. When you put a root 3, what do you get? It's negative 9 for both, yeah? Hopefully. Yes, thank you. And then now, what is the point of maximum? Again, you only find from the chart the value of x. Maximum is 0 and what? Just 0? Maximum is only 0. So what is it? The y value is easy for 0. Of course, he's found it 0. When you put x 0, the y value is 0. So I'm sure Artan did the same. 0, 0, yes. Wasim too. Thank you. So we found the points of minima and maxima. We found the increasing and decreasing intervals. And actually, we are using, this is what do we call this? This is sign chart is first derivative test. First derivative test. We didn't spell it out like that, but that is sign chart. The sign chart will tell us the first derivative test, because first derivative test states that when passing from the left to right of a critical number, if the slope goes from negative to positive, then it's a minimum point. If it goes from positive to negative, then the critical number is a point of maxima. This is, we have used it already. So we have used the 3 steps. Of course, the graph is quite easy. I don't want to keep you at 0 is my critical number. The other critical number is at negative root 3, which is 1.7, negative 1.7, I guess. And root 3 is right here at positive 1.7. So here, the 3 points have, so here is negative 9. Somewhere here, we have a critical number. Somewhere here, we have a critical number, but a critical point here. So these are minimum. Both of them are minimum, local minimum. So that must be like this, because they are minimum points. At the maximum, this got to be like that, because it's maximum, you see? So we are kind of able to sketch right away. And then the increasing from this side, it's decreasing from this side, because our interval state increasing and then decreasing and then increasing. So kind of, it's not very clear yet, because we are really we don't know critical, x-intercepts, right? And we don't know inflection points, where they are turning, from going down to going up, which is what we call inflection points. Once we add the inflection points, the x-intercepts, the graph is done. Really, how complicated graph we were able to do using differentiation. Okay, does it make, do I make sense?
Except the x-intercept, sometimes we have to use a Newton method for some polynomials, right? They are difficult to find. Yeah.
Yes, yes. This one is very easy, but we're not there. I don't want to take your time. It's already beyond 10 minutes from class, so I don't know. We're gonna do that next class. The x-intercepts in this case is very easy. What are they? It is actually x to the 4 minus 6x squared. X to the 4 for x-intercepts. x of 4 minus 6x squared equals 0. Because there is common, it's easy. X squared minus 6 equals 0. This implies x equals 0, x equal to plus or minus root 6, right? But sometimes it's difficult, you're right. Okay, am I right?
Sir, one last comment. Like one of the colleagues, I think 2 class ago, he said that the vertex is the derivative of the parabola. And I think by that time, it was not, he was mentioning, and actually even the equation, like for the vertex, it came from the differentiation of the parabolic equation.
Yes, yes. The vertex actually is a derivative at the point of the derivative. When the derivative equal to 0,
To zero,
you
yes.
find the vertex.
Thank you.
The x component of the vertex. Is that what you're saying, Wissam? Or
Yes, sir. Just mentioning that because it's stuck like unresolved and just
no? I mean, for only parabola, it's very specific. You know,
yes,
if it's
parabola.
only parabola,
Yes, sir.
that point for x value, that x value,
Yeah.
if you get y equal to f of x, if you do dy by dx equal to 0, you find that x definitely.
Like even the equation you mentioned is was it ax square plus bx plus c equal to 0, right? And if you
So yeah,
derive
we
that
have y equal
equation,
to ax squared plus
yes,
bx
if you derive
plus
that
c equals 0.
equation and equal it to 0, then you will get the same equation that you put for the vertex.
Yes, you're right. So x0 we said is minus b over 2a, and we find the derivative of this, which is 2a plus b, and 2ax plus
Yes,
b equals 0. Then 2ax is minus b, and then x is minus b over 2a. That's right. You're right.
yeah, thank you, sir.
Okay, you're welcome. Perfect. But we didn't know derivatives when we sketched earlier. I couldn't have used this. I mean, even though we know, we were not at that stage. But the formula x equal to minus b over 2a came from the derivative concept. He's right. Okay. So at the turning point, you can find the derivative of the parabola and equate to 0. That will be the what you call the turning point. Okay. So the x-intercepts for this graph are straightforward because we are lucky to factor x squared. Okay. So the x-intercept means when y equal to 0. That's it. You don't involve derivatives. When y equals to 0, you factor x squared minus 6 equals 0, and then this is equal to 0, and this is equal to 0. We'll give you those numbers. So there is x equals 0 as an x-intercept, root 6, and here is the other x-intercept. Here is the other x-intercept. Okay. Okay. Is everybody okay? I'm very happy that you have
Yes,
the
sir.
patience to wait like 13 minutes, 17 minutes after the class. But I really appreciate it. But it is beyond, if you have, I hope you have no class. Okay, I have to stop recording it.